Welcome back, dear students, to part 2 of our lesson orthogonality. By the end of this video, you will be able to define the mediator plane of a segment and to state the steps to prove that a plane is the mediator plane of a segment. As usual, please prepare your textbook, pens, draft paper, your copybook, and your geometry set. First of all, what is a mediator plane? Well, the definition states that the mediator plane of a segment AB is the plane perpendicular to AB at its midpoint I. Let's say this is our segment AB, and this is its midpoint I. As we said, the mediator plane of this segment is the plane perpendicular to it at its midpoint. Property. Any point belonging to the mediator plane of a segment AB is equidistant from the two extremities A and B. As you can see, all these points belonging to the mediator plane have the same distance from both A and B. As an example, let ABCD be a regular tetrahedron. M is the midpoint of CD. Please remember that all faces in a regular tetrahedron are equilateral triangles. Prove that A and B is the mediator plane of CD. Well, as we said before, the mediator plane of a segment is the plane perpendicular to the segment at its midpoint. To prove that CD is perpendicular to A and B, we need to prove that it is perpendicular or orthogonal to two intersecting lines in A and B. So is CD perpendicular or orthogonal to AM, to AB, to MB? This is the plane A and B, and this is our segment CD. We know that CD is perpendicular to AM, since a median is also a height in the equilateral triangle ACD, as you can see in the figure. Similarly, we know that CD is perpendicular to BM because a median is also a height in the equilateral triangle BCD. AM and BM intersect in point M, then CD is perpendicular to plane A and B. Plane A and B intersects the segment CD at its midpoint M. Then, we can say that plane A and B is the mediator plane of segment CD, since it is the plane perpendicular to the segment at its midpoint. As an application, let ABC be a right isosceles triangle such that AB equals AC. D is a line perpendicular to plane ABC at A, and S is a point on D such that SA equals AB, as you can see in the following figure. Part A. Show that the line AB is perpendicular to plane SAC. Please pause the video and give yourself some time to think. Well, we know that ABC is right at A, thus AB is perpendicular to AC. We also know that line D is perpendicular to plane ABC at A and S is on D, so line SA is perpendicular to plane ABC. So SA is perpendicular to AB, perpendicular to AC, and it is orthogonal to BC. Now, how can we prove that AB is perpendicular to plane SAC? As usual, we should prove that AB is perpendicular or orthogonal to two intersecting lines in SAC. Is it perpendicular or orthogonal to SA, to SC, to AC? This is our line SA that is perpendicular to plane ABC. And this is the line AB that we are proving perpendicular to plane SAC. Now, we know that AB is perpendicular to AC since ABC is a right triangle at A. We also know that AB is perpendicular to SA since SA is perpendicular to plane ABC and AB is a subset of this plane. AC and SA intersect in point A, Thus, line AB is perpendicular to plane SAC. Part B. Let H be the midpoint of segment SC. Show that the plane ABH is the mediator plane of SC. Please pause the video again and give yourself some time to think. So what do we have? We know that line AB is perpendicular to plane SAC, as we proved in Part A. And we know that H is the point of this plane. So AB is either perpendicular or orthogonal to all the lines contained in this plane. Now, to prove that the plane ABH is the mediator plane of segment SC, first we should prove that SC is perpendicular to plane ABH, and then we should say that ABH intersects segment SC at its midpoint. Now, why is SC perpendicular to plane ABH? Is it perpendicular or orthogonal to AB, to AH, to BH? Remember, we need two intersecting lines in plane ABH. Well, first of all, what we have is that line SC is perpendicular to line AH, since the median AH issued from the main vertex is also a height in the isosceles triangle SAC. We also know that SC is perpendicular to AB, since AB is perpendicular to plane SAC and SC is a subset of this plane. AH and AB intersect in point A. Then SC is perpendicular to plane AHB, and AHB cuts the segment SC at its midpoint H. Thus, we can say that the plane AHB is now the mediator plane of segment SC, since it is perpendicular to this segment at its midpoint H. As a homework, please review page 308 on your textbook and solve exercise 13, parts A, B, and C, page 350. The following summary summarizes all the main ideas we have taken so far. Coming next, in our next video, we will learn how to define the dihedral angle formed by two intersecting planes and list the steps that are sufficient to determine such angle. We will also learn how to list the theorems concerning the proof of two perpendicular planes. Till then, please ask your teacher for any further questions.